Okay, people, welcome back to another video. Great, awesome. By the way, this is crazy. On 13 videos, we have 14 subscribers. People are loving this, I suppose. Right? We are getting a lot of views actually for some reason, and that is good, I guess. मतलब basically this is amazing. ठीक है? क्योंकि last video में I think we had 12 subscribers or something, and today we have 2 more subscribers, and that is amazing. राइट और अभी हमने सीरीज शुरू भी नहीं करी है ढंग से लाइक व्हाट 6 videos max 7 8 या 8 videos एंड दिस इज जस्ट ऑन ट्राई हैक मी राइट मैं अदर कंटेंट भी बनाना चाहता हूँ जैसे कि व्हाट इज रियल वाईफाई पेन टेस्टिंग क्योंकि तुम वाईफाई पेन टेस्टिंग करोगे तुम्हें दिखेगा कि ये तो काम नहीं कर रहा है रियल वेज आई वुड लव टू टीच यू गाइज जिसमें हम 4 5 अडाप्टर यूज़ करेंगे लाइक पूरा एक वाईफाई पाइनएप्पल टाइप ही बना देंगे अपने लैपटॉप को बिल्कुल एक वाईफाई पाइनएप्पल बना देंगे अपने लैपटॉप को लाइक ऐसे काम करना चाहते हैं हम तो या we have a lot more we have a lot of things to cover which we will I would love to you know and show some real hacking other than the studying we are just doing. But Joe, today we are in penetration testing frameworks. By the way, whoever have subscribed, thank you very much. I love that. तो वीडियोस थोड़े स्लो आ रहे हैं क्योंकि 12 दिन पहले सीधे फिर 3 दिन पहले लाइक व्हाट हैपेंड टू द 9 days but now 2 days. I was going to put out a video every day लेकिन वही है कि टाइम नहीं मिलता and you know some things fuck up etc. Ooh, we are going to bronze league. हमेशा मैं गोल्ड तक आते आते ब्रॉन्ज हो जाता हूँ. But okay, it doesn't matter. Let's start the video. Penetration testing frameworks. Explore the landscape of penetration testing frameworks. All right. Introduction. Imagine you just landed your first penetration testing engagement. The client is mid-sized e-commerce company and they want you to evaluate the security of their web application, internal network, and employee security awareness. You sit down, open your laptop, and then what? Do you start running Nmap right away? Do you do you test the login page for SQL injection first? Do you try phishing an employee? Without structure approach, a penetration test quickly becomes a disorganized collection of random checks. Wait, let me zoom in. Yes. You might miss critical attack surface, skip important documentation, or deliver findings that the client cannot act on. Worse, you might test systems that were never in scope and find yourself in legal trouble. Oh shit. This is exactly the problem with penetration testing framework solve. Great. A penetration testing framework is structured methodology that guides security professionals through every stage of engagement, from initial planning and scoping to exploitation. Reporting and remediation validation. Consider the analogy of a building inspector following a code compliance checklist. The inspector does not wander through the building hoping to notice problems. Instead, they follow a systematic process that ensures every structural element, electrical system, and fire safety measure is evaluated against a known standard. Penetration testing framework serves the same purpose for security assessment. Relying on structured methodology provides several benefits. Ensure thoroughness so the critical areas are not overlooked. It promotes consistency so the different testers on the same team produce comparable results. It supports compliance by aligning the assessment with regulatory requirements. It also improves communication because clients, auditors, and stakeholders can understand and trust a process grounded in recognized standard. There are many penetration testing frameworks in active use today, and each has its own philosophy, strengths, and ideal use cases. In this room, we will explore the following in depth. Open Source Security Testing Methodology Manual, OSSTMM, a scientific metrics-driven approach to security testing, scientific metric, okay. OWASP, this is the most common one by the way. Web Security Testing Guide, the go-to framework for web app assessments. NIST, Special Publication 800115, the US Government Technical Guide to Security Testing and Assessment. Penetration Testing Execution Standard PTES, a practical space-driven standard that mirrors how real engagements are conducted. Ooh, this is what you guys are looking for, by the way. Information System Security Assessment Framework, ISSAF, a historically influential methodology with a detailed 9-step assessment model. That is crazy. I think we should look at this. Wow, look at that. This is a huge PDF. Whoa, look at that. What the hell? 1200 pages. No, 1264 pages. Oh my god. पता है क्या? If you guys want to torture me, you can ask for a video about this and I will go through all of this in 7 or 8 hours. I don't care. Because this looks like crazy work. Obviously, we are not going to read this, but look how this is a great PDF, by the way. Just because I see this risk equals asset value into threats into vulnerabilities. That increases the risk. That is great. Methodology. Wow. Actions, countermeasures. This is a crazy PDF and this is free. We also have PTES. This is what we were looking for. This is simple. Very simple actually. Just a single page. High level organized standard. Penetration testing across 7 main sections. Okay, these are the 7 sections. Oh shit. I said I said it too early. This is not simple. Post exploitation, damn, sensitive data, key logging, screen capture, user information, password policy. Damn, we are cooked. Are these subgroups? No, no, no. Okay. Wow. These 7 things has their own pages, and these pages have so much intelligence gathering. All of these are this huge, man. By the way, not secure. You can inject something if someone goes to this page. That is crazy. We have NIST. Again, bro, what the? 80 pages. That is crazy. That is crazy. OWASP should be smaller though, right? Yeah. Yeah, I read it multiple times. This is, well, I have heard about this too many times, but I've never read it. But yeah, this looks okay, like not bad. Linking, web application security, reference scenario. Yeah, sure. Okay. And we have open source security testing methodology manual. It's the biggest name ever. It's loading, bro. This is okay. 213 pages only. Not bad. At least it's not this one. 1264 pages, brother. I'll shoot myself before I read this. Crazy. Yeah, but this is nice. These are nice PDFs, which someday you guys might have to read, depending on which one you are going for. Okay, now let's read. We will also introduce MITRE attack. Yeah, this one. Every kind of attack possible. Discovery techniques, credential access techniques, reconnaissance, privilege escalation, persistence, stealth, pre-OS boot. Yeah, this is the best shit ever for persistence, but it's the hardest too. But yeah, MITRE attack is great. Watch it. As complementary knowledge base that maps adversaries' tactics and techniques, we will survey several other notable frameworks, including WASC threat classification, CSA cloud control matrix, OWASP mobile application security testing guide, PCI DSS penetration testing guidelines, and CBEST framework. Do you know when and where they apply? Damn, this is huge. Too much information in one topic. Yeah, how is this 60 minutes? No way in hell this is 60 minutes, brother. I will never accept that. This is not 60 minutes. This alone would take fucking 10 to 20 hours if you actually go through all of this. Okay, whatever. Learning objectives. Describe the purpose and structure of the major penetration testing framework. Compare frameworks based on their scope, methodology, and intended use case. Select an appropriate framework for given engagement scenario. Explain how MITRE ATT&CK complements traditional penetration testing methodologies. Prerequisites: familiarity with basic networking concepts, a general understanding of what penetration testing involves. Okay, this is simple. Everyone should know these without even any teaching. A penetration tester runs several tools against a target but skips network mapping entirely and does not document the scope beforehand. Which benefit of using frame which benefit of using a framework would have most directly prevented the situation? Ooh, he's asking which benefit of using a framework? Thoroughness. Yes. Your client operates in healthcare sector and must demonstrate compliance with HIPAA. Beyond identifying vulnerabilities, which benefit of using a recognized framework would matter the most to the client? 100% consistency. Oh no, it's compliance maybe. Yeah, I think it's compliance because he's saying ki compliance exactly. Demonstrate compliance with HIPAA. So of course we basically thoroughness, compliance, consistency, and communication. These are the only things that matter. Oh, we will go through all of these. All right. OSSTMM. You have probably heard the phrase you cannot manage what you cannot measure. In most engineering disciplines, quantification is a given. Structural engineer does not declare a bridge safe based on intuition. Yet in penetration testing, findings are often delivered as subjective narratives. The open source security testing methodology manual aims to change that. Developed by the Institute for Security and Open Methodologies, the OSSTMM, currently at version 3, applies the scientific method to security testing. Its defining characteristics is metrics over opinions rather than delivering subject risk judgment. OSSTMM produces countable, verifiable, and repeatable results. OSSTMM organized testing around 5 security channels, reflecting its philosophy that security is not just a network problem. Human security, social engineering and human factor vulnerability, physical security, physical access controls from badge readers to tailgating. Actually, I would love to know about this. Yeah, exactly. This is in security. In cybersecurity, physical security, tailgating, piggybacking is a breach method where an author follows an authorization. Oh, okay. Piggybacking basically, tailgating is wireless communication, Wi-Fi, Bluetooth, RFID, and other electromagnetic signals. Telecommunications, phone systems, VoIP, fax, modem infrastructure, data networks, network services, firewalls, and application layer protocols. Okay. An organization might have flawless firewall rules, but if an attacker can tailgate into the server room or social engineer a credential reset, those network controls become irrelevant. The 5 channels ensure nothing is overlooked. At the heart of OSSTMM, quantitative approach are risk assessment values, a RAV, risk assessment values, measure the balance between the total attack surface and controls protecting it. A positive RAV indicates residual risk. RAV near zero suggests controls are well matched to exposure. This numeric output means that two testers assigning the same target should arrive at the comparable results, much as two engineers measuring the same beam should calculate the similar stress tolerance. Wow, this is great. Phases, a walkthrough. OSSTMM testing cycle has 4 phases. Let's walk through them using scenario. Your team is assessing the external network of FinVault Corp, a financial services company scoped to this IP and the subnet, and their customer portal at portal.finvaultcorp.thm. Phase 1 Introduction covers enumeration and verification. You map what exists and confirm it is real. At FinVault, you query DNS, review certificate transparency logs, and discover subdomains like VPN and mail. You then verify each asset is live and responsive. The output is confirmed inventory of the target environment. Alright. Phase 2 Interaction covers qualification and quantification. You actively probe the verified assets and assess their relevance. At FinVault, you connect to each service, fingerprint as technology, and quantify the exposure. 12 externally reachable services across 8 hosts. 4 of which accept unauthenticated connections. These findings feed directly into the attack surface calculation. Okay. So you do introduction, interaction, and now you do inquiry. Covers privilege escalation and verification escalation. Your test whether the measured exposure can be converted into unauthorized access. At Finvault, you discover an IDOR vulnerability in the customer portal that allows one authenticated user to read another customer's account statements. Verification escalation confirms the scope. Read access to 12,000 account, but no write access. Okay. Phase 4 intervention covers quantitative audit and enticement. You address findings and examine the bro- broader control environment. At Finvault, the vulnerable endpoint is restricted. At the same time, a patch is developed. Quarantine, the wider access control model is examined for similar flaws. A canary token is deployed to test internal detection capabilities. Okay, so this is a patch is a quarantine, examining is audit, and enticement is deploying something to detect capabilities. Closing note. OSSTMM prescribes the security test audits star format for deliverables, enforcing consistency and enabling cross-team comparability. It's a scientific rigor. Its scientific rigor is both its greatest strength and its primary barrier. The OSSTMM frameworks makes results auditable and comparable, which is rare in penetration testing. However, the learning curve is steep. Full implementation can be time consuming, and experienced OSS TMM practitioners are harder to find than those who trained in OWASP or NIST methodologies. OSS TMM is best suited for organizations that need repeatable, auditable security measurements and are willing to invest in mastering the methodology. Ooh, okay, so this must be expensive. OSS TMM. If you read this one, then you might be able to get a very good job. I'm guessing because this is rare OSSTMM, but you need to learn this by heart. Okay, whatever. Let's see what questions we have. What OSSTMM metric quantifies the balance between an organization attack service and its controls? Ooh, isn't it this one introduction? Because this is where you actually, okay, metric, OSSM metrics. Hmm. Okay, metrics over opinions. Oh, wait, this is the one we are talking about? No. What OSSM metrics qualifies a balance between an organization's attack surface and its controls? We will look at this later. But between organization attack surface and its controls. Wait, this does not hit my head. Wait. Oh, these are the ones, right? So these are security channels, and he's asking attack service and its controls between 5 security channels. Okay. Risk assessment, of course. Wait, let me see. How am I forgetting this? Risk. At the heart of quantitative approaches are risk assessment values. Okay, this makes sense. A RAV measures the balance between the total attack surface exposure. Yes. Okay, I forgot this. No worries, this happens. During an OSSTMM assessment, you complete introduction and interaction, identifying 6 hosts running unpatched services. Which phase do you enter next, and what is the primary objective? Of course, we have done introduction and interaction. So we will, of course, inquiry should be the next one, right? Because we will tell them ki what has happened. Yes. Okay, great. You are testing a web application for an online retailer. The application handles user registration, product search and shopping cart, payment processing, and order tracking. Where do you even begin? Do you test the login form first, the search bar, the payment API with dozens of potential attack services in a single web application? It is easy to either test the same things twice or miss entire vulnerability classes altogether. The open source web application security project addresses the problem with web security testing guide. While OWASP is the most widely known for OS top 10 list of critical web vulnerabilities, the WSTG goes far deeper. It's comprehensive community-driven framework that organizes web application testing into over 90 discrete test cases grouped across 12 categories. I think we should read this one because web application pen testing is the harder pen testing more than a Active Directory or privilege escalation. Web apps are much more harder. Those 12 categories span the full attack surface of a modern web application. They include information gathering, configuration and deployment management, identity management, authentication, authorization, session management, input validation, error handling, cryptography, business logic, client-side testing, and API testing. Each category contains numbered test case. Example WSTG INPV1 for reflected cross-site scripting with the step-by-step guidance on what to test and how to test it. Oh wow. The WSTG adopts a risk-based approach. Vulnerabilities are prioritized based on their exploitability and impact, not simply catalog. This approach means the framework helps testers focus on the efforts where they matter most. Phases: security across SDLC. What sets the WSTG apart from many penetration testing frameworks is that it does not treat security as a single event. Instead, it aligns testing across 5 phases of the software development lifecycle (SDLC), embedded security from initial planning through post-launch maintenance. Let's see how this works for our online retailer ShopSecure Incorporated, which is building a new customer portal. Phase 1: before development begins, security requirements and regulatory obligations are established upfront. For Shop Secure, this means defining the portal must comply with the PCI DSS since It processes payments and establishing measurable criteria such as maximum acceptance time for patching vulnerabilities. During definition and design, the application architecture is reviewed for security flaws before any code is written. Shop Secure team creates threat models for payment flow, identifying that a checkout API will be high value target and designing rate limiting and input validation controls from the start. Phase 3. During development, code is vetted through walkthroughs and reviews. Shop Secure developers review the authentication module against WSTG test case for credential handling, identifying a flaw in which password reset token do not expire. Phase 4. During patch deployment, security controls are verified in production environment. Shop Secure teams runs a penetration test against the stage application, verifying the default credential have been changed, the TLS is properly configured, and no debug endpoints are exposed. Phase 5. During maintenance and operation, security is maintained post-launch through periodic health checks, especially after updates. When ShopSecure pushes a new product recommendation feature 3 months later, the relevant WSTG test cases are re-executed to ensure the updates has not introduced new vulnerabilities. Closing notes. The WSTG greatest strength is exhaustive practical coverage over 90 test cases, each containing specific procedure and expected results. It gives tester a concrete roadmap rather than abstract principles. It also benefits from continuous updates from global community of security professionals, keeping it current with emerging vulnerabilities, classes, and modern architectures such as SPAs and microservices. On the downside of full implementation of every test case can be impractical for resource-constrained teams. Some teams require specialized expertise in areas like cryptographic analysis or business logic testing. There is also risk of falling into checklist mentality where testers may mechanically execute test cases without stepping back to assess the application's overall risk posture. The best practitioners use WSTG as a foundation while applying critical thinking beyond the checklist. The WSTG organizes its test case using a specific identifier format. Sorry. What identifier would you look for in the find test case? Related to input validation. Input. What identifier would you look for to find test cases related to identifier? Right. If we are talking about identifiers, then We should actually look into this. Answer is probably here or somewhere. Because he's saying organize the test cases using specific identifier format. What identifier would you look for to test? Search करने को ही बोलेगा ये. Yeah, this is about searching this. Input validation के लिए कौन सा use होता है? So we can just search the WSTG input validation testing. There are so many. Look, there are these names. Is it this one? Does it want the whole thing? No. Yeah, but this is the thing. You look for input validation, right? So if I just search this INPV, if I go back to this INPV, okay, this it just needed this whole thing. This is input validation. Yes. Okay, a development team has just finished coding a new feature that wants to check it against WSTG before deployment. Which STLC align phase number are they in? Wait, it's just development, so there are 4. What? During development, brother? I mean, oh, sorry, 3. Deployment. I read deployment, it's 3. Okay, let's move on. NIST SP 800115. I'm not going to read this again and again. Consider the scenario you work as a security analyst for government agency or a large enterprise that contracts with federal government. Your organization needs a security assessment, but the results may just satisfy auditors, comply with federal guidelines, and be defensible in the event of oversight inquiries. A penetration testing report full of informal, complimentary, and subjective risk ratings won't cut it. You need a methodology that federal regulators recognize and trust. This is the niche filled by NIST. Okay, yeah, NIST. I'll just call this NIST. A titled Technical Guide to Information Security Testing and Assessment, published by the National Institute of Standards and Technology, NIST. This document provides a foundational framework for systematically evaluating the security posture of information systems. While it originated in the US federal context, its principles are broadly applicable and widely adopted in private sector, especially by organizations that value structure repeatable process. NIST-SP is not a penetration testing framework in the narrow sense. It is broader. It covers full spectrum of security testing and assessment techniques, from document reviews and logs analysis to vulnerability scanning and full penetration tests. It treats penetration tests as one technique among several, all of which serve the goal of validating whether security controls work as intended. 3 core objectives drive the framework. First, identify vulnerabilities in systems, networks, and applications. Second, validate security controls by testing whether they perform as expected under adversarial conditions. Third, assess exploitability by simulating real world attack scenarios to determine whether the threat actor can actually leverage identified weakness. Phases. NIST structures testing into 3 phases. Let's walk through them with a scenario. Your team has been engaged to assess the security of GOVNet, a mid-sized federal agency internal network spanning 500 hosts, 3 data centers, and a public-facing citizen service portal. Phase 1. Planning. Before any test begins, the objectives, scope, and rules of engagement are formally defined in the or documented. For GOVNet, this means specifying which network segments are in scope, the citizen portal and supported backend, and which are excluded, the classified enclave. It also means establishing communication protocols, who gets notified if a critical vulnerability is found mid-test, what hours testing is permitted, and constitutes an emergency stop condition. The planning phase produces a formal test plan that all stakeholders sign off. Phase 2, execution. This is where active testing happens. NIST groups execution activities into 4 techniques categories. Review techniques, examining the documentation, policy, system configuration, and rule sets. At GovNet, this includes reviewing firewall rules and access control lists for misconfiguration, target identification and analysis, discovering the fingerprinting live host, open ports, running services. At GovNet, you scan citizen portal infrastructure and identify 12 internet-facing services. Target vulnerability validation, confirming that identified weaknesses are real and exploitable, not false positive. At GovNet, a scan flags as potential SQL injection. On the portal search function, you manually validate it by crafting a test query that returns database version information. Penetration testing, simulating adversarial attacks to test the depth of the exploitation possible. At GovNet, you chain the confirmed SQL injection with privilege escalation on the database server to demonstrate that an external attacker could access internal citizen records. Notice how NIST treats these as progression from passive to active, from low impact to high impact. Not every engagement needs to reach the penetration testing stage. Sometimes a review and vulnerability validation are sufficient to objective. Assessments for the assessments objective. Phase 3, post testing. The focus shift to analyzing results, prioritizing risk, and delivering actionable immediate remediation strategies. For GovNet, this means categorizing findings by severity. The SQL injection chain is critical. The missing HTTP security header is low, of course. Mapping each finding to the specific control it bypasses and providing concrete remediation steps. NIST emphasizes that findings should be actionable. Telling the client you have SQL injection is not enough though. Explaining which parameter is vulnerable, what data is at risk, and how to remediate it standard. Obviously, this is obvious in every single penetration test. Closing notes. NIST strengths lie in flexibility and institutional capability. It adapts to diverse environments from traditional data centers to cloud infrastructure and IoT deployments because it defines technique categories rather than prescribing specific tools. Its associate with NIST gives it immediate recognition in government, defense, and regulated infrastructure. Sorry, in the industries. It also promotes standardization, making it easier for organizations with multiple testing teams to maintain consistent quality. On the downside, it does not enforce the audit frequencies or penalties, unlike PCI DSS, payment card industry, which mandates annual penetration tests. NIST is guidance, not regulation. This can limit its adoption on as a standalone driver as highly regulated sector. It also requires skilled personnel. The framework assumes tester can execute the full range of techniques from document review to exploitation, which handles a broad skill set. Answer the following question. During the execution phase, your vulnerability scanner flags 15 potential issues on web application. Before attempting exploitation, which NIST technique category should you apply to those findings? This is easy. Uh, this is you're going to target the vulnerability validation. Yeah. Okay, let's go PTES. Damn, this is a huge one. It's been 32 minutes and we are still reading this non-stop. No issues. Let's see if we can complete this in 60 minutes. Overview. You have now seen frameworks that emphasize scientific metrics, web application coverage, and government-aligned assessment techniques. But here's a question worth considering. If you were hired tomorrow for standard penetration testing engagement against a corporate network, which framework would you closely mirror the actual workflow you would follow from the first client to call the final report delivery? For many working pen testers, the answer is Penetration Testing Execution Standard (PTES). This is an important one. Available at penetration standard.org. PTES was developed by a group of experienced security practitioners with a specific goal to define what a real penetration test looks like end to end, where other frameworks focus on what to test and how to measure. PTES focus on how the engagement flows from start to finish. PTES is organized into 7 phases that maps directly to lifecycle of penetration testing engagement. This approach makes it exceptionally practical for junior testers because it answers the question that many frameworks leave impact. I have signed a contract, now what do I do on day 1, day 2, and every day after? Phases. Wait a second. Okay, hello people. थोड़ा सा break ले लिया मैंने. Okay, yeah, phases, a walkthrough. Let's walk through the 7 phases during a 7 phases. Kill me. This is gonna be a huge one again. Uh, 7 phases using a scenario. A healthcare company, MedGuard Health, has hired your team to perform full penetration test on their corporate network and patient record portal. Phase 1. Pre-engagement interaction. This is everything that happens before testing begins. You define the scope with MedGuard's IT director, the corporate LAN, the patient portal at this, and wireless networks that are headquarters building. You document the rules of engagement, including testing windows, weeknights only to avoid disrupt clinical operation, emergency contacts, and a get out of jail free letter authorizing the test. Ooh. PTES is notably detailed and here because unclear scoping is a number one source of legal professional disputes in penetration testing. Brother, I am cooked. Actually, we all are cooked. Phase 2, intelligence gathering. You collect information about MedGuards using both passive and active techniques. Passive reconnaissance includes harvesting employee emails addresses from LinkedIn, discovering subdomains through certificate transparency log, and reviewing job posting that reveal technology stacks. Seeking a DBA with Oracle 19 experience. Active reconnaissance involve DNS enumeration and network scanning within the agreed scope. PTES distinguishes between these levels because the depth of intelligence gathering directly shapes the quality of subsequent phases. Phase 3. Okay, so it's pre-engagement intelligence gathering. सबसे पहले पता करना है कि क्या क्या है. इंटेलिजेंस गैदरिंग में भी यही है. यहाँ पे लीगल बातें हैं. यहाँ पे हम शुरू करते हैं. थ्रेट मॉडल क्या है? Using the intelligence gathered, you identify the most valuable targets and the most likely attack paths. At MedGuard, the patient record database is the highest value asset. Your threat model identifies two primary attack vectors, paths. Uh, Compromising the patient portal directly through web vulnerability or pivoting to the corporate LAN after compromising employee workstation. This phase ensures your testing efforts is directly by adversarial logic rather than random scanning. Vulnerability analysis. You systematically identify weakness that could enable the attack path from your threat model. At Mudguard, vulnerability scanning reveals that the patient portal is running an outdated version of Apache Tomcat, which contains a known deserialization vulnerability. On the internal network, several workstations are mission critical patches. PTES emphasis that vulnerability analysis includes both automated scanning and manual verification to eliminate false positives. Post exploitation. Okay, no, sorry, I mean exploitation. You attempt to exploit the confirmed vulnerabilities at Medpad. You exploit the Tomcat deserialization flaw to gain a shell on the portal server. That's crazy. On internal side, you use a phishing pretext authorized in the scope. Ooh, to deliver a payload to an employee workstation. Wait, you're already inside and then you are doing a phishing attack from inside the network. That is crazy. BDS stresses that exploitation should be purposeful. The goal is to demonstrate business impact, not to pop boxes for the sake of it. I would go straight to this, man. I would not give a shit. I would just go to this. Let me hack every single box. I want to see everything I can hack. But this is not how it should be done. Phase 6, post-exploitation. After getting access, you determine the real-world impact. From the compromised portal server, you pivot into the backend database and confirm read access to patient records from the employee workstation. Ooh. You extract a cache domain credentials and demonstrate lateral movement to a file server containing financial data. PTES treats post-exploitation as a phase where technical findings are translated into business risk. We accessed 50,000 patient records. Carry far more weight than we got a shell. Bro, but we got a shell. That is why we were able to get to access 50,000 patient records. Without this, how would we do this? What the hell? Okay. Phase 7. Reporting. You deliver the findings in a structured report within two audiences in mind. The executive summary communicates business risk in plain language for MedGuard's leadership. Patient data was accessible. Regulatory exposure under HIPAA, health information profile. Okay, is significant and remediation is urgent. The technical report provides the details and MedGuard's IT team needs to reproduce and fix each finding. Ex- exact exploitation steps affected host evidence screenshot and prioritizing remediation guidance. Closing notes. PTES greatest strength is practical end-to-end structure. It reads like a playbook for how engagement actually unfolds, which makes it an excellent learning framework for junior tester building the workflow instance. Its detailed treatment for pay engagement interaction is particularly valuable. Many frameworks gloss over scoping and legal authorization, which are precisely the areas where inexperienced testers make costly mistakes. On the downside, PTES has not formally updated in several years. That's crazy. And the technical guidance sections reference outdated tools and techniques. The methodology and phase structure remains sound, but testers should supplement PTES tool specific guidance with current documentation. It also lacks quantitative metrics of OSSTMM, so results depend more on individual tester judgment. Which PTS phase number specifically address defining scope, rules of engagement, legal? I think this is one. Yeah. For a penetration tester, yeah, one. Oh, okay. ISSAF. Have you ever studied the? It's been 41 minutes. Have you ever studied a vintage textbook found that despite its age, the core logic still holds up? In cybersecurity, tools and exploits have short shelf life, but well-designed methodologies can outlast the technologies they were built to test. The Information System Security Assessment Framework in case in point developed by the Open Information System Security Group. ISSAF is an open source penetration testing framework designed to evaluate network system and application security. The latest version, ISSAF, was published around 2006. This is the latest version, and the framework is no longer actively maintained. Then why are we reading about this? There is no longer official URL to download it. However, the draft can still be found through archived solutions sources online. This is important context. ISSAF methodology and phase structure remain instructive, but its tool specific guidance is outdated and should not be relied upon for current engagement. So exactly. So why study a framework that is no longer maintained? Because IFS 9-step assessment model is one of the clearest representation of how an attacker progresses through a target environment. It mirrors the logic of an advanced persistent threat, moving systematically from initial reconnaissance to persistent access and removal of evidence. If that progression sounds familiar, it should. It is the kill chain thinking you have encountered in detail that cyber kill chain from earlier rooms in this model. Oh. ISS covers a broad range of security domains, including network infrastructure, host systems. This is basically like the Pythagoras theorem. That people ask, why should we study Pythagoras even though we don't use it in real life? It's for just for your understanding. It's just for your mental ability to improve. Okay, where were we? Covers broad range of security domain, including infrastructure, host system, web application, database, social engineering. Its risk-based approach prioritizes high-impact exploitable vulnerabilities over low-severity finding. All right, phases. Damn. Phases. Walkthrough. ISSAF divides an assessment into 3 phases. That's crazy. Let's walk through them with a scenario. Your team is assessing the security tech bridge solutions, a software development company with over 200 employees, an internal Git server, and a client-facing project management portal. Basically a Git TA server. Right. Yeah, Git T official website. Phase 1, planning and preparation. The phases are set engagement boundaries. You meet with the technical based CTO. Oh, Chief Technology Officer. Redefines the scope, corporate network, Git server, and a project management portal. Establish escalation protocol and emergency contacts. Identify constraints. The projection Git server must not be disrupted during business hours, and agree on the toolset appropriate for the assessment. Phase 2. This is the core ISSAF where its 9-step model lives. Each step builds on the previous one, simulating how a real adversary would progress through the environment. Information gathering. Collect the publicly available data about TechBridge, DNS records, who is data, employee profiles on LinkedIn, and technology references in job posting. Experience with Jenkins and GitLab's CI required. All feed your understanding of the target. Network mapping. Map the live network topology, your discovered TechBridge external IP range, host and project portal, a VPN gateway, a mail server. Internal scanning once in scope reveals the Git server, the Jenkins build server, and several developer workstation. Vulnerability identification. Scan the MAP addresses for weakness. The project portals runs on the outdated CMS with a known authentication bypass. The Jenkins server has its administrative console exposed without authentication. That is crazy, not possible almost. Penetration testing. Sorry, penetration. Attempt initial exploitation. You exploit the unauthenticated Jenkins console to execute system commands on the build server. That's crazy. Gaining access privilege escalation. Escalate from initial access to higher privileges from the Jenkins server. You recover stored credential for the service accounts that deploys code to production, which has administrative right on the Git server. Of course, it does. Enumerating further, with elevated access, enumerate what is now reachable from Git server. You discover repositories containing API keys, database connection strings, and client project source code. Obviously, what a lateral movement. Compromise remote users sites. Lateral movement. Move laterally to other systems using harvested credential. You access several developer workstation and the internal mail server. I really wonder how good this must feel to hack all of this. Maintaining access. Establish persistent access to demonstrate that a real attacker could retain their foothold. You document without actually deploying how a backdoor could be planted in CI/CD pipeline. Persistence across system reboots and deployments. Covering tracks. Demonstrate how an attacker could erase evidence. You document which logs capture your activity and identify gaps in the TechBridge logging that would allow real adversary to operate undetected. Yeah, basically get root and remove all the fucking logs. Notice the progression. Each step deepens the attacker's position in environment. Step 1 to 3 reconnaissance analysis. Step 4 to 7 are active compromise. Step 8 to 9 address persistence and stealth. Basically MITRE attack framework. Uh, Reporting and cleanup. You compile finding into structure report prioritized by the business impact. The unauthenticated Jenkins console is flagged as critical because it provided the initial foothold that led to source code access. Cleanup will involve removing any test artifact, revoking any temporary accounts created during testing, and confirming with TechBridge team that no testing residue remains in their environment. Closing notes. ISSAF 9-step model is lasting contribution. The progression from information gathering through lateral movement to covering tracks provides a clear mental model for how real-world attacks unfold, making it an excellent educational tool even though the framework itself is no longer maintained. However, that unmaintained status is a real limitation. The tool-specific guidance references software versions that are over a decade out of date and there is no community updating the documentation. ISSAF should be studied for its methodology and adversarial logic, not for its technical procedure. For current tool guidance, supplement with the resources such as PTES, OWASP, or WSTG, or the other relevant tool information. Okay. ISSAF 9-step assessment model begins with information gathering. What is the ninth and final step? Covering tracks. Let's go. MITRE attack framework. Okay. Give me a second. Give me a second. Like, you guys can forward the video. Okay, yeah, I'm back. So we were at MITRE. In previous tasks, we explored framework that tell you how to conduct penetration test, how to scope it, progress through the phases, and report your finding. But consider the situation: you have just completed an engagement using PTES and report document that you gain initial access through phishing email, escalated privilege of exploiting misconfiguration service, move laterally using stolen credential, exploited data through an encrypted channel. Your client reads the report and asks a deceptively simple question: how does our exposure compare to what real threat actors are actually doing in the wild? That question is difficult to answer with penetration testing framework alone. Frameworks like PTES, OSSTMM secure your testing process, but they do not systematically catalog the specific tactics and techniques that real-world adversaries use. This is the gap MITRE attack framework fills. Attack stands for adversarial tactics, techniques, and common knowledge developed and maintained by MITRE Corporation. So, it's not a traditional penetration testing framework, it's a knowledge base of adversary behavior built for real world observation of how threat actors operate. It catalogs what attackers do, organized in a structure that security professional can use for threat intelligence, detection, engineering, threat teaming, and relevant to this room. Enriching penetration testing fields. The matrix, tactics, techniques, subtechniques. Wait, other notable frameworks. Hmm. Attack is organized as matrix. Think of it as large table of the columns represent tactics, which are the adversary's high level objective. The why behind an action, the current enterprise matrix includes 14 tactics progressing from initial access through execution, persistence, privilege escalation, defensive evasion, and credential access, discovery, lateral movement, collection, command and control, exfiltration, and impact. Within each tactic column, the row lists techniques, which are the how specific methods an adversary uses to achieve tactical objective. For example, under the initial access tactic, you will find techniques like phishing, exploit public facing application, and valid accounts. Many techniques are further broken down into subcategories. Phishing, for instance, has subcategory for spear phishing attachment, spear phishing links, and spear phishing via service. Each technique entry in the attack knowledge base includes a description, a real world example of threat groups that have used it, detection, recommendation, and mitigation. This is what makes attack more than taxonomy. It is a living reference tied to observed or adversary behavior. Attack as complement, not as its replacement. Here's the key distinction for this room. Attack does not tell you how to run a penetration test. It does not define phases, scoping procedure, or reporting formats. Instead, it provides a common language for describing what you found during a test conducted using any framework. Instead, it provides common language for describing what you found during test conducted using any framework. Consider the analogy of medical dictionary versus a diagnostic procedure. PTES is like a diagnostic procedure. It tells the doctor what steps to follow during examination. Attack is like the medical dictionary. It provides standardized terminology for naming and categorizing what a doctor observes. You need both, but they serve different purpose. Walk through mapping findings to attack. Let's see how this works in practice. So recall the MedGuard health engagement from task 5. Here is how the key finding engagement map to attack. Phishing email delivered, initial access, this. Phishing spear phishing attachment, this. Exploited Tomcat discharger flow, initial access, exploit application, this. Extracted cache domain credential from workstation, credential access, OS credential dumping, this. Yeah, so this is very obvious. This is the MITRE attack. If I copy this, wow, we cannot find this. 003 OS credential dumping era. And this is where is the sub techniques T1003. T1003. Move from workstation to file server using stored credential, lateral movement, use alternative authentication material. Access patient records database from compromised portal collection. By annotating a PTS report with attack techniques IDs, the Testford Medguard security team with actionable insights beyond patching individual vulnerabilities. The client can now look up each technique in the attack knowledge base, review a detection guidance, and build or validate detection rules for those specific behaviors. The conversion shift from fix this one bug to can we detect this class of adversary behavior? Closing notes. Attack's strength lies in its role as universal translator of adversary behavior. It enables penetration testers, threat intelligence analysis, detection engineers, and incident responders to speak the same language. For a penetration tester, specifically, mapping findings to attack elevates a report from a list of vulnerabilities to a narrative grounded in real-world threat behavior. The knowledge base is extensive and mastering it takes time. The enterprise matrix alone contains over 200 techniques. For a deeper hands-on exploration of attack, including how to navigate the matrix, research specific threat groups, and apply to detection engineering. Dedicated rooms later in TryHackMe platform cover attack in far detail. For now, essential takeaway is this: attack complements your chosen penetration testing framework by providing standardized vocabulary for what you find. In attack matrix, what do the columns represent? What? Subcategories. These are really high level objective. The why. What do you mean by the column represent? Tactics. Column represent tactics. Oh, okay. Yeah, that makes sense. In attack matrix, what do the rows within subcategories, right? Techniques. Yeah. Kind of subcategories, kind of. You compromise the web server by exploiting unpatched vulnerability in its public-facing application. What attack technique ID would you use to classify the finding? You know what? Let's go here. We have gotten initial access by what attack technique? Wait, public-facing unpatched vulnerability. Exploit public-facing application. This is T11. This. Yes. Other notable frameworks. Wow, it's been 1 hour, 59 minutes by the way. And we still have so much to read. See, this is the issue, man. This feels so huge. But whatever, let's do it. Okay, so let's go with other notable frameworks. Overview, the framework we have covered so far: OSSTMM, OWASP, WSTG, NIST, PTES, ISSAF, and MITRE ATT&CK represent the core methodologies and knowledge bases a junior penetration tester is most likely to encounter. But the landscape does not end here. Depending on the industry, platform, or regulatory environment your client operates in, you may need to be aware of more specialized frameworks that address specific domains. This task surveys 5 additional frameworks. Wow. The goal is not deep mystery of each one, but landscape awareness, knowing they exist, understanding their niche, and recognizing when a client engagement might call for one of them. The framework WASC Threat Classification was developed by Web Application Security. What is this? Consortium? A group of companies that work closely together for a particular purpose. Consortium. Okay. Web Application Security Consortium as a taxonomy for categorizing web application vulnerabilities and attack types. It organizes threat into categories such as insufficient authentication, information leakage, and abuse of functionality. While it was influential in mid-2000s, and it helped standardize how the industry discussed web threats. It has since been largely supersessed, supersessed to take place in something which I guess is okay.
supersede,
Supersede. It has largely been superseded by the OWASP Top 10 and WSTG as the dominant web security references. You may still encounter it referenced in older documentation or compliance frameworks. I thought this is written supersized. CSA, Cloud Controls Matrix, is published by Cloud Security Alliance and provides a cybersecurity control framework specifically designed for cloud computing environment. It maps controls across 17 domains, including data security, identity and access management, and industry infrastructure infrastructure security, and aligns them with major standards like ISO, NIST, and PCI DSS. Oh yeah, payment card one. CCM is not a penetration testing methodology. It is a governance and compliance tool that helps organizations assess whether their cloud providers and configurations meet security requirements. You would encounter it when a client needs a cloud security posture assessment rather than a traditional pen test. OWASP Mobile Application Security Testing Guide is the mobile counterpart to WSTG. We covered in task 3, maintained by OWASP. The MASTG provides detailed test causes for Android and iOS application security, covering areas like data storage, cryptographic implementation, and network communication, platform interaction, and code quality. If your engagement involves testing mobile banking app, a healthcare patient portal app, or any client-facing mobile application, the MASTG is the go-to reference. It is used alongside the OWASP Mobile Application Security Verification Standard, MASVS, which defines security requirements that the MASTG test against. PCI DSS penetration testing guidelines are defined within the payment card industry data security standard PCI DSS, specifically in requirement 11.14. Unlike the general purpose framework covered earlier, these guidelines are regulatory mandates any organization that process, stores, or transmits cardholder data must conduct penetration tests that meet PCI DSS criteria. The guidelines specify that tests must cover both external perimeter and internal network, must be conducted at least annually after significant infrastructure changes, and must validate network segmentation controls. When your client is retailer, payment processor, or any entry in the payment card ecosystem, PCI DSS requirements will shape both the scope and reporting format of your engagement. CBEST framework was developed by the Bank of England in collaboration with the UK financial sector. It is a threat intelligence led penetration testing framework designed specifically for UK financial institutions, including banks, insurers, and financial market infrastructure providers. CBEST engagements begin with a bespoke threat intelligence phase that identifies the most relevant threat actors and attack scenarios for the specific institution, and the subsequent penetration test simulates those realistic threat scenarios. CBEST is notable for its close integration of threat intelligence with hands-on testing for its regulatory banking within UK financial sector. Great. Comparison table. Primary domain, type, actively maintained, uh, when you would use it. Oh, this is a great one. Okay, let's read this. Framework is WSC, threat classification, primary is web application, type is threat taxonomy, actively maintained is no, supersized by OWASP, superseded by OWASP. When would you use it? Legacy in references. So basically not, you will not use it. CSA, cloud control matrix, cloud environments, governance compliance controls, actively maintained yes, cloud security posture assessment, OWASP mobile application security testing, mobile applications, Android iOS testing guide, and it's actively maintained. When you would use it, mobile application testing, PCI DSS, payment card environments, regulatory mandate, Yes, current is version 4.0. Any engagement involving cardholder data. CBEST, UK financial sector, threat in Intel-led pen testing, yes. Engagement with UK financial institutions. Closing notes. The key takeaway from this survey is that framework selection is driven by context. The client industry, regulatory obligations, technology, platform, and geographic jurisdiction all influence which frameworks apply. A penetration tester working with UK bank must understand CBEST. A tester assessing a mobile health application will reach for OWASP MASTG. A tester working with payment processor cannot avoid PCI DSS requirements. Knowing the landscape means you can recognize which framework a given engagement demands, even if you need to study in detail at that point. Okay, so knowing you should at least know what you are going to pen test. So you could choose your own framework. Okay, let's answer some questions which I wonder I won't be able to do. Let's see. Your client is a European online retailer that processes credit card payment processing through their website. Which framework for this task would most likely govern the penetration testing requirement for this engagement? So, of course, we are going with credit cards, so it should be PCI DSS, right? Let's go with this one. But it's not because they are going to ask for this web application because it has online retailer, right? Through their website. So we are going to test the website thingy. But this is what I kind of don't like about this web application. Wait, it might not be this one. It should be that one, the first one, not open source. It is going to be this one, Open Web Application Security Project. But no, not this one either. Where is the... So they are asking for payment processing and web application at the same time. Right, so it should be here. Um, Wait, which framework from task would directly govern the presentation? Client is European online retailer that processes credit card payments. Now they are talking about credit card payments. So shouldn't it be payment card in this? Or are we just supposed to put this? No way. This is what this is very, yeah. We already encountered this issue. एक बार पहले भी हम same issue आ चुका है. क्योंकि it is the payment thing you will use, right? It is the PCI DSS, but they want to see the short form and then testing guidelines. Oh, fuck this. A client asks you to assess the security of their iOS banking application, including how it stores credentials locally and communicates with backend APIs. Which framework for this task is most appropriate for testing? Of course, it's going to be OWASP MASTG, but wait, it's just the application, so we don't need OWASP. We only need this. Yes. We don't need, yeah, it is MASTG, exactly. Your team is evaluating clients' AWS infrastructure to determine whether their cloud configuration meet industry security standard. They are not asking for a penetration test, but rather a control assessment. Which framework is the most relevant? So it's a cloud environment, so they should go for this one. CSA Cloud Matrix. Yes. Let's go with the choosing the right framework overview. You have now worked knowledge several penetration testing framework, each with its own philosophy, structure, and strength. But knowing what each framework is does not automatically tell you which one to use. In practice, framework selection is one of the first decision penetration testers makes after receiving an engagement brief. It is a decision shaped by multiple factors that often pull in different directions. Consider the analogy of a mechanic's toolbox. A mechanic does not use every tool on every job. They select the tools based on the vehicle, the problem, and customer expectations. A penetration tester operates the same way. The right framework depends on the client's industry, the type of system being tested, the regulatory landscape, and engagement's objective. This task walks through the key selection criteria and then presents realistic scenarios for you to practice on the decision. Selection criteria: four factors consistently drive frameworks selection in real-world engagement. Engagement scope and target type is the most immediate filter. A web application assessment aligns with the OWASP WSTG. A mobile application engagement calls for OWASP MASTG. A full spectrum network penetration aligns naturally with PTES or OSSTMM. If the scope spans multiple channels, including physical and human factors, OSSTMM's five-channel model becomes particularly relevant. Regulatory and compliance requirements can override personal preference entirely. If the client processes payment card data, PCI DSS penetration testing guidelines are not optional. If the client is a UK financial institution subject to Bank of England oversight, CBEST may be mandated. NIST SP carries weight in US government and federal contractor environment. When regulatory dictates, the texter adapts. Need for quantifiable, repetitive results matters when multiple assessors are involved or when results may be compared across time periods. OSSTMM's RAV metrics, RAV, risk assessment value, yes, are specifically designed for this. If the client says we want to measure whether our security posture has improved since last year's test, OSSTMM provides the measurement framework to objectively answer that question. Team expertise and available resources are practical constraints that are easy to overlook. A full OSSTMM implementation requires deep familiarity with its metric system. CBEST demands threat intelligence capabilities. For a smaller team conducting a standard corporate network assessment, PTES offers a practical, well-structured workflow without the overhead of more specialized framework. Scenario practice. Let's apply these criteria to realistic situations. For each scenario, consider which framework you would recommend and why. Scenario 1. A regional hospital hires your team to test their patient facing web portal and internal network it connects to. The hospital must comply with the HIPAA, but it's not subjected to PCI DSS, it's outsourcing payment processing. Okay. They want a structured end to end assessment with clear executive summary for the board of directors. PTS is a strong fit here. It provides the end to end engagement structure with hospital needs. It reporting explicitly produces a both executive and technical deliverables, and it covers both a web application and network testing within a single methodology. OSWSTG can supplement the web portal testing specifically and mapping findings to MITRE attack techniques. ID would strengthen the report by grounding it in real world threat behavior. Scenario 2. A multinational bank headquartered in London needs a penetration test that satisfied its UK regulatory obligation. The engagement must begin with a threat intelligence assessment specific to institution. CBEST is a clear notice. It designed for UK financial institutions. The mandates a bespoke threat intelligence phase and it's recognized by the Bank of England. No general purpose framework alone would satisfy the requirements. A SaaS startup wants two different security firms independently test its platform over the next 2 years and compare the results directly to track improvement. The platform is entirely web-based. OSSTMM's RAFs metrics enable direct cross-team, cross-time comparison that clients is requesting. OWASP WSTG would guide the specific test carries, while OSSTMM provides quantitative measure layers that makes year-over-year comparison meaningful. Scenario 4. Scenario 4. A fintech company asks you to test their Android and iOS mobile banking applications, both of which handle credit card transactions. This engagement requires two frameworks working together. OWASP WST, uh, OWASP MASTG provides the test case for mobile application security for both platforms. PCI-DSS penetration testing guideline must also be followed because the application handle cardholder data. The tester needs to satisfy both mobile specific testing methodology and regulatory mandatory mandates simultaneously. So basically, you can use two. The more the technology is being used, the more of frameworks you'll be using. If the technology has web and cardholder payment info, then you'll use OWASP. right? And you will also use this PIS, PCI, sorry, DSS, right? And they also want you to do internal pen testing, so then you'll use PTES. Then they want you to, after your penetration test, they want you to specify things, so you'll use MITRE ATT&CK. So basically, you will use everything eventually. Okay, let's go with the closing notes. Wait, we did this? No. As the scenarios illustrate, Kafir framework selection is rarely a single choice. Real engagements often involve primary framework that structures the overall methodology and supplementary frameworks that addresses specific regulatory, platform, or reporting requirements. The ability to recognize which frameworks apply and how they complement each other is a skill that distinguishes a methodological penetration tester from someone who simply runs tools. Biggest difference between a penetration tester and just some script kiddie. Uh, because if you don't read this penetration testing framework, this is a premium room for a reason. If you don't read this room, you will not be able to tell what you are doing, basically. And you will not be able to say it, कि मैं क्या कर रहा हूँ, what am I doing, what framework am I choosing for this pen test. So yeah, a US federal agency needs security assessment on its internal network. The result must align with the federal guidelines, and assessment should include both document reviews and active penetration testing. Which framework is most naturally prime? Okay, so they want federation, right? So I'm guessing this should use PTES should be here, but we are also going to go with they really want internal network, but they are the US government. So we read this one. Maybe it's this one, NIST, because it's weight in US government. So yeah, we'll just go with this one. Yes, NIST SP 800. Your client is an e-commerce company with web storefront, a mobile shopping app, and a payment processing system. Which combination of frameworks would you recommend to cover all the components? Exactly. So webfront is OSWP, OSAP, Open Web Application Security Project. So yeah, they should go with OWASP. Why can't I copy this? Okay, crazy. And now why is it not OWASP? You will done, but okay, you will go with WSTG. Sure. WSTG, then it's the mobile application app. So we'll be using that one. We just read it. OWASP, MASTG. Exactly. So then we'll use MASTG. Yes, MASTG. Yeah. So WSTG, MASTG. Wait, MASTG. And then we will use PCI DSS. Yes. Yes, let's go. It took me a little while because I was thinking all the frameworks we'll be using. Yeah, okay. So in this room, we'll explore the landscape of penetration testing frameworks, moving from question, why do frameworks matter, to the practical skill of selecting the right one for given engagement. Okay, so it's just this. We begin with the OSM. Okay, master the channels. What comes next? Okay, so let's do this view site. We begin with OSSTMM. It's scientific metrics driven philosophy where the security is not Okay, so let's do this. Operator doser penetration testing frameworks. Prepared by your mentor for your eyes only. Frameworks are not paperwork, they are the difference between a thorough engagement and expensive mistake. Your mentor left 4 drills in this dossier, each one practicing a judgment call you will make on a real client engagement. Open the first file when you're ready. Briefing. Your mentor left this dossier on your desk before heading to client side. The 4 drills inside are drawn from real engagements. Work them in order. Each one test a judgment call you will make in the field. OSSTMM channel recognize the 5 security channels that collectively describe organization full attack service, ISSAF. Sequence the 9-step attacker progression from reconnaissance through persistence and stealth. Attack mapping, map engagement findings to MITRE attack tactics using the standardized vocabulary. Framework selection, select the right framework stack for client scenario based on scope, regulation, and deliverables. Mentor note, quantitative metrics, the OSSM RAV provides a numerical score for security posture, and it's not a pass-fail grade. It is a baseline your measure change against. When a client asks, "Are we secure?" the RAV lets you answer with, "We are 73%," and here's what moved the needle. Okay, attack service walkthrough. Every marker belongs to one of the OSSM 5 security channel. Identify all 5 security. Complete the exercise. Wait. So channel tracking. I can click on it. Conference, open office, break server room, storage. So I can just click on it. What am I supposed to do? Okay, sure. Okay. Physical security, dumpster diving, fence bypass, piggybacking through smokers, entrance, the attack surface starts properly line, proceed. Place 9 step into order, attacker would execute them, check your sequence with all slots are filled. Oh, okay. Wait, so do you want me to, oh, this is how. Okay, I can just change this. So yeah, of course, the first one is going to be information gathering. Second one is going to be network mapping. Wait, in use build server access to prove internal. No, that will come later. How do I put this? Okay, network mapping. Third will be vulnerability identifications. Wait a second. Yeah, third will be vulnerability identification. Come on, go up. Okay, yeah. Then fourth will be compromise remote user site, lateral movement, no. Internal enumeration, penetration. Yeah, let's go penetration. Fifth will be uh, internal enumeration. Then sixth will be compromising remote users. Then seventh should be, wait, if I am the hacker, I would actually do this, and then I would do this, and then I would do this, and then I would do, see, this is the thing. Actually, I would do this, okay, and then I would do this, and then I would do this, and then I would do this. This is how I would do it. Okay, I will penetration, okay, I have penetrated, then I will maintain the access to whatever my privileges are. And then after I know that I have my access, I have my backdoor, I will try to gain access and privilege, right? I will escalate my privilege, and then I would maintain that access again just to be secure. And then I would do internal enumeration, and then I would laterally move, and then I will cover the tracks. But the issue is, this will probably be wrong in the eyes of TryHackMe. This will probably be the this will probably be wrong in the eyes of TryHackMe, because what they would expect is, I'm just guessing, gaining access and privilege escalation should be before maintaining access. I bet that they will think this. And after you have access, you will gain internal enumeration. But I will check it. Exactly. It's wrong. Exactly. That is the exact thing that is wrong. So, penetration ke baad, I will of course do this. No, sorry. This. And then we will do this. Then we will do this. And then this. And now this is right. Wait, this is still wrong. What the hell? So you'll gain access. You have privilege escalation. Then you will not maintain access. What the hell? You are asking me to laterally move and then maintain access. Come on, brother. That is stupid. Okay. Okay, but you are try hack me, I believe you more. But this is crazy. Internal enumeration. So you have penetrated the thingy, penetrated the system. Then you are doing privilege escalation without maintaining any backdoor. So you are hoping that you will exploit the vulnerability again, right? And then you will do without, still you have not access. You don't have a backdoor installed yet, right? So just in case you lose this access because of a mistaken privilege escalation, right? Anything like the EDR killed your backdoor, or you did some privesc and it broke the server, right? You will have to do all of this again. You have no you don't have a backdoor. I really believe maintaining access should be here, but it's all right. So you are getting privilege escalation and then you still don't have access to maintaining access. So you'll do internal enumeration, right? And then you'll compromise those computers and then you'll maintain access. That is crazy. I would not do it like this because this is risky. Let's say you get a shell. Now that shell is your only option right now. So you should get a better shell by maintaining access. But okay, whatever. Steps 1 to 3 are reconnaissance and for active compromise. Stealth, you just walk the real adversary flows. Sure, proceed to tactics. Map each engagement finding to attack tactics in represents. Not every column will be used. Submit when ready. Phishing, initial access. Encrypted patient, no. Credential access, yes. Credential access. Lateral movement. Move Moved from workstation to file server using Stoller. Yeah, lateral movement. Accessed, that is collection. And impact is every file is encrypted. Exactly. Let's go. So finding proceed engagement router. 3 client briefs, work each one. A framework stack has to satisfy scope, regulation, and deliverable expectation at the same time. Work each one. A framework stack has to satisfy scope, regulation, and deliverable expectation at the same time. Oh, okay. UK, primary target type. Yep. Primary framework will be NIST. Wait, how is this wrong? Okay, okay, it's bank. CBST. Yes. Supplementary frameworks. Uh, Wait, what is the question? Penetration testing satisfy UK regulator. The engagement must begin with the base intelligence phase. I'm guessing PCI as well, but no. OWASP then, yeah. I was confused between these two because I thought ki it's a bank, then it should have credit cards, but I guess they don't care about that. Okay. Supplementary this OWASP WSTG for any web components. Rationale correct. CPST governs the engagement. OWASP provides the detailed methodology. Attack strengthening reports. Choose next scenario. Regional hospital. Uh, Target type, engagement shape. A regional hospital needs structure end-to-end pen test for its patient-facing web portal, patient-facing portal, and internal network, plus a clear executive summary for the board. HIPPA applies, PCI does not. Payment is outsourced. Regulate. Sorry. Compare. It should be compare. Oh my god. Should be that, yes. Target type, engagement shape. Patient waiting internal network. Now PTES. Yes, I was waiting for this. Supplementary frameworks. We would go with WST for portal. Yes. Choose next scenario. A fintech company asks you to test Android, iOS banking apps. Both handle credit card transaction. Okay. Uh, Regulatory mandate. Yes. Then we'll go with OWASP MSTG for mobile application. Supplementary frameworks. Supplementary, we'll go with PCI. And yes, that is done. Field is ready, and we have the flag. Great. So let's go. Should I read this? Wait, this is the same thing we just did, actually. Web application 90 structure. Yeah, we just did this actually, so we don't need this. But we'll read this. What comes next? The room focused on frameworks that structure how penetration testing planned, executed, and reported. In pen test methodologies and reporting module, we'll cover threat modeling for penetration, pen planning, and scope. These rooms will formalize it further, giving you adversarial mindset and complements the methodological discipline you have built here. Great. Okay. Okay. Now this is going to be a little harder. So finally, we have done penetration testing foundations. Now it's time for network reconnaissance, a little bit of hacking. I'll redo this with you guys, of course. So yeah, thanks for watching. And I just saw that we have 16 subs. That is crazy good. 16 subs and 13 videos. I love that. And thank you. I cannot pronounce your name, but whoever you are, thank you very much for subscribing. Wow, we are on 82 views on this one. That's great. Okay. Bye, people. I hope you enjoyed.